So right, I'm Sarune Savickaite. I'm a second year PhD candidate at the University of Glasgow School of Psychology, and I'm working with David Simmons, who's here, and another PhD student, Elliot Millington, was chairing the conference before and is also a co-organizer of the conference. And my PhD is on the use of VR to understand in a perceptual world of autism. And I will run through things we do in our small little lab, and what I've done so far in my PhD and what are sort of the next steps. So about us is it's sort of all the VR aspect of autism related research has started with, I think it probably started with my PhD and then carried on with Elliot's. And it is an industrial partnership with Edify, our industrial partners. And we are working, and Edify is sort of more focused on the immersive teaching side. And as part of our PhDs, we tend to focus on autism and particularly the sensory aspects of autism. And my secondary supervisor is from School of Humanities, Dr. Neil MacDonald. So this is just us three for now, but we are moving forward. It's myself, like I said, Dr. David Simmons and Elliot. So currently we have my project, which is using virtual reality to understand in a perceptual world of autism, and I'm sort of halfway through. And Elliot is just starting off his PhD using virtual reality technology to examine the relationship between sensory sensitivity and anxiety and autism. So we are kind of more focused on the sensory sensitivity and the sensory aspect of autism, if you like. So I wanted to share that this is the preprint that I've just posted a few weeks ago of this is the first of many papers to come, hopefully this year, on the first set of tasks that I've done in virtual reality and it is on the visual processing styles. And I will briefly describe the sort of general overview of what the task was like. And I'll share the link to the preprint and our website at the end of the talk as well. So the inspiration for this came from a few different sources. One of which was the autobiographical accounts of the fragmented world, where self-reports from autistic individuals themselves, they often suggest a sort of very fragmented world, sensory sensitivity, hypersensitivity to visual stimuli, even seeing small particles in the air. And like I said, sensory sensitivity, not just visual, but we kind of focus more on sort of the visual side of things, at least for my PhD. And then the local versus global visual processing debate in autism, and which, if you've done autism research, you might have heard of or are familiar with. It has been sort of back and forth, and it's a little bit controversial topic, but the research is still going on. And what it is essentially is that it's proposed that perhaps autistic people have a more local predisposition, which means just paying extra attention to details of the visual scene rather than extracting the gist of the information, which would be the global visual processing style. Then on top of that, we looked at some inspirational autistic people such as Temple Grandin and Stephen Wiltshire. Temple Grandin often talks about seeing the world in pictures. And Stephen Wiltshire, if you're familiar, he draws these absolutely amazing, detailed drawings of landscapes just from memory. So all of this sort of meshed together, we kind of came up with the first set of experiments, and then hopefully that will lead to further down into my PhD. For some reason, it's not wanting to show the little animations I had. Hold on, let me just make sure I refresh it and reshare it. Technical difficulties, sorry. Right, there it is. So here, this is at the top, you can see a NAVN task, which is very commonly used in local and sort of versus global processing experiments. And it illustrates the sort of local versus global paradigm. So if you are more locally inclined, then you will notice smaller details in these two figures, such as the little circles or the rectangles or squares rather over here. But if you tend to perceive things globally, you'll see the rectangle and the circle. And what we chose to use in the task as sort of a baseline was the Ray-Osterried complex figure task, which is this one at the bottom. It is very widely used neuropsychological test in many different settings, but it is used in local versus global processing and individual differences in autism and ADHD as well. And in here, this little graphic at the bottom shows the sort of global way of drawing this figure, which is drawing the rectangle first, then the lines, and then smaller elements. The task itself is very simple. You present it with the sort of a two-dimensional black and white simple drawing in front of you. You copy it, then it's taken away, you recall it from memory immediately, and then you recall it again after a short delay. And up until now, it's been used as a pen and paper task, or it's been used as in the tablet, which is another sort of little project we have going on. But what we decided to do is import this figure into the 3 dimensions and use it in virtual reality. So this seems to be like a sound is on, but ignore the little clicks of tilt brush. So we did use just a simple drawing tool, tilt brush, like I said. You can see the different perspectives from various experimental conditions. And there was a bunch of data that we have collected. So the questionnaires we used to assess different individual differences. And these were neurotypical participants, I must say. These were not diagnosed autistic individuals. We looked for autistic traits using AQ, the Autism Coefficient Questionnaire. And we looked at ADHD traits as well, which were measured by ASRS questionnaire, which from the top of my head, I will not remember what that abbreviation stands for. Then we videotaped them from this first person perspective, which was sort of probably the easiest way of collecting the data. And then on top of that, I also did some fancy coordinate extraction. So I managed to get these 3-dimensional sketches out of tilt brush and painstakingly convert them into CSV files and eventually visualize them as 3-dimensional figures in R. And these are just examples of copy, immediate, and delayed conditions. We did compare some aspects of these 3-dimensional figures, but it's kind of ongoing whether we're going to pursue the sort of 3-dimensional aspect of this particular drawing, just because it tends to be a very 2-dimensional figure. And then we did the scoring of the figure itself. There's a lot of different scoring systems. We picked 2. One was the sort of perceptual scoring system, which just captures how accurate they are at drawing. So you can see how many elements they remember essentially. And then we did the organizational scoring, which relies on this very global processing of the figure, like I showed in the previous slide, that you draw the square first, then you fill in the processing lines and then small elements. And then organizational score reflected that. So this is not presented in this figure, but we did seem to find that amongst many other things, that attention to detail subscale of AQ seems to impact organizational scores in particular and perceptual performance. We're kind of trying to figure out what that might mean. And on top of that, we found some interesting patterns emerge from the way people process this particular figure. And these are the 3 different patterns that at the bottom. So you can, alongside your very standard global processing or drawing style, which would be the scenario C, where you have just rectangular, then larger lines, and smaller elements. Alongside, there were a few other strategies, such as B, which was drawing an outline and then filling in the details from outside inwards. And then the quite common one as well was from left to right or right to left, where you start sort of the figure rather than as a sort of the whole, you fill it in from one side to the next. So one of the undergraduate students did look into these individual patterns and trying to identify them. I'm still in the process of getting that data together into a paper, so stay tuned. But it does seem to be that there's something interesting going on. So the question is, what would we do next and how we're going to investigate this? So there are a few elements here that we're still trying to get the head around because there's just so many different levels of information we can tackle. So the first bit that we're going to do next is we're working on working memory experiment in virtual reality. So looking into these very standard tasks such as a Navin task or visual search task that's used in local versus global processing paradigm research, and get them into VR and see if we're getting some sort of interesting results, because Ray Oster complex figure task seems to indicate something interesting. So perhaps we could look into visual spatial memory in particular and identify something interesting there. And then the creativity and visual processing styles. This sort of has a few strands which I'm hoping to pursue in the remaining of my PhD and maybe even in the postdoc, fingers crossed. But I've just, because of the COVID-19, our data collection has been slightly delayed. So I have had a online drawing task where we used a similar paradigm of a person creating their own drawing this time and then drawing it from memory, and then after a short delay, but I introduced a slightly different questionnaire around the cognitive styles and see if that might shed some sort of light as to perhaps there's an issue with the questionnaire, particularly because some subscales of AQ showing results where others don't. So I'm trying to sort of untangle that. And then the next step is also to strip down tilt brush and leave only the most crucial elements, such as just a few colors, a few brushes, because there's a lot of information, especially when you're navigating tilt brush, it's a lot to learn. So perhaps that's quite overwhelming. So with tilt brush becoming an open source, we can take away quite a lot of functionality, keep only the basic one, and then see if we can get diagnosed autistic individuals to do some sort of visual task and see what results we get from that. So just to mention also, Elliot has started his PhD this year. So he is developing a virtual environment, which is the picture of it, which is presented here. But I think Elliot is probably best to explain this slide here and then just say a few words on his experiment before I move forward.
Sorry, yes. So just following the train there. I mean, I am only in my first year of the PhD, and as you say, with COVID-19, it's impossible to do quite a lot. But the general aim of this project is to use some of the advantages that we have with VR and apply them to this almost theoretical work. So, for example, looking very specifically at how the senses and anxiety in autism interact. And one of the benefits of technology like standalone VR is that we can take headsets into people's homes or where they already feel comfortable, and then do this work without having to worry about giving people directions or maintaining things being on time. And so some of the preliminary work that we've done on this has been just through the web, and we've been finding that it's almost surprisingly that people find some visual scenes and some sounds that are easily put into VR very relaxing. So we're looking at sort of how sensory sensitivities change when they're in these more relaxing or maybe more stressful environments. So it's all very preliminary until we can get people into headsets.
And I think then I just have essentially just the contact information, which I shared with you. If you're interested, there's our lab website where we have some general information. There's my personal website if you're interested in some other things I'm doing. There's my own Twitter, and then David shared his. There's the link to the preprint for the sort of the first set of data that I've managed to put in the paper, but more coming. And then the presentation slides, which were on Canva, so you can access them yourself. So that's me. I'll stop sharing and you can ask me any questions if you have any.
I have a question.
Yep.
I just wondered whether you found any differences between the 2D and 3D images in your experiment.
well, we didn't compare the two-dimensional task, but we happened to have another experiment going with the tablet and iPad, which is we're just in progress of getting that out as a paper. And interestingly, though, although I initially suspected that there might be an issue with having a two-dimensional image in the three-dimensional world, but the bit that emerged, which was consistent in both the two-dimensional task and the VR task, was the attention to detail subscale and how well people performed on the organizational scoring scale, which was, if you remember, how well they kind of drew the drawing with the sort of global style, if you like.
Yeah.
So that was interesting. But in the VR, we had more participants, but the data was quite spread out, so it's hard to say whether that effect would remain. And there were some other subscales that emerged in VR. Don't know whether that's something that we will pursue further, but there's a lot of data. So in a short period of time, I tried to include quite a bit, but yes, so it seems like there is not as many differences that we potentially expected in the 2D versus 3D.
Okay, thank you.
Any other questions or comments?
I have a quick question, and it's really more to those just a couple of final slides and related to, I don't know if you've gotten this far. I'm curious how you're thinking about measuring anxiety.
That's for Elliot.
Sorry, I'll jump in. I mean, the initial thought that we had was just to do everything and see what worked, just because you look into it and everyone has an idea. You've got heart rate, maybe variability, sweat, everything, and then you sort of look at it and you go, oh, it's not that good. And so almost my intention was sort of do the traditional questionnaire approach, sort of before, after, and then really just see what sticks. Certainly in the pilot stuff anyway. And then once we have a better idea of what's actually effective for what we're looking at, which may be the key part of it, is which aspects of physiological anxiety or reported anxiety are the most important. But yeah, I mean, there's nothing clean is basically my answer there.
Yeah, no one's really done that in VR yet, and it's an area that I'm looking into. And the issue is, like, we can definitely figure out what the arousal is, right? And we have to kind of infer if that arousal is anxiety or if it's good arousal. And so how do you figure out the valence of the arousal is the question I've got. I don't have an answer to it, but maybe you do. So I'm curious if you could speak to that.
I really wish I did, just because it is the key question. And it does get into the heart of the theoretical question, I guess, of when you're looking at this anxiety, because obviously we always assume that it's just one thing. And I mean, so for example, I've been looking at splitting it where we've got sort of long-term chronic anxiety tendency towards anxiety, as well as the immediate anxiety of what the person is feeling in the moment, and then how that interacts with everything. So I wish I had a good answer for you, but until almost we've got in there,
yeah,
we don't really know.
That's a crucial difference, wouldn't it? Because the trait anxiety or anything that you observe within the environment, the virtual environment, it would be essentially just the biological measures, that the biometrics that you might have. But if it is a trait anxiety, not a trait, but the state anxiety, just sort of general anxiety, feeling of anxiety, which in autism some people might have, then the question is that probably wouldn't be captured with the biometrics. So that, I think that's when the VR becomes a little bit more, at least when, I don't know exactly much about Elliot's research because it's just starting, but if it is sort of a calming environment, then it goes into this whole VR use for meditation or mindfulness therapy and see if that sort of has an effect, because that would work perhaps more for the state anxiety rather than trait anxiety, where trait anxiety would be interventions such as mask youth work in the Newcastle and things like intervention and the more like phobia stuff, isn't it?
So one thing that's quickly occurred to me as well is that one of the unique things that we might be able to use in VR is with the eye tracking equipment that's now available, and looking at pupil dilation and the variability of pupil dilation, which is potential. I mean, it measures arousal, but I think depending on how we calibrate everything, could be quite good for that as well.
Yeah, these conversations are mirroring some conversations that we're having over here, particularly what you mentioned about mindfulness. And yeah, I don't mean to dominate the discussion, but really fascinating stuff. And I'd love to follow up and learn more about it.
Yes, so definitely we'll follow up. Before I carry on with that, does anyone got any particular questions for me or Elliot while we're here? Or for David, because David's here as well. Nope. Okay, well, we've got the links, but on that, in terms of, because I think we talked about so many interesting topics and there's so many potential strands to follow up the conversation. So I think this is a good time to mention that we were thinking of having these sort of regular journal clubs where we could meet up people interested in VR research applications in autism, and we can sort of brew on these collaborations or share ideas or share new research or anything that we are working on. So in terms of that, I will share, first of all, the YouTube channel for our current conference, where we will be uploading the videos that have been recorded of the talks. And at the moment, the channel is empty, and it just has those little promos that we made for the conference. Then there's got our Twitter account, where I've tried to make sure that we mention all the speakers. You can start the conversations on what each speaker has spoken about. And then a little separate website that I put together for the journal club, which is still under construction, if you like, because we're waiting for the conference to finish, and then we can follow up and decide how often we're going to meet, what time we're going to meet, just to make sure that we can have all the international participants together and sort of follow up that way, and then interact with each other and carry on this nice sort of little group of AVRA research, which is our little abbreviation for the conference. Any other last minute comments for today?
Just want to say well done to the team for organising this fascinating first day, and I will look forward to the next 2 days. I should say that I've done practically nothing to help with this, which is just the way I like it. So well done to you all for that. Yeah, it's really interesting, and I think what I see, I mean, you know, I do sort of see this as the emergence of something really good. As some of you might know, that we tried to start a special interest group at INSAR this year on virtual reality and autism, which didn't fly because we didn't have enough variability in the participants. But I think we'd certainly be competitive next year if we can put something together. So that might be something, although we have been talking about this year's INSAR, which we were all at last week, was rather focused on the medical model. At least a lot of the bits of it that we've seen, the keynotes and some of the more highlighted presentations. So I think we've got some work to do in that respect as well. And I was pleased to see, Matthew, that you agree with us on that we need to very much think more in terms of the social model. But yeah, so thank you very much, everyone. That was a really interesting couple of hours, and thank you to all the speakers as well.
And the last year we did try to arrange the sort of a miniature trial run of this, which was just myself. So I will share on Twitter the link to those talks which were recorded. But this time around we had a team, which was a lot easier, which is why this conference has become a little bit bigger. So thanks to Tammy, Elliot, Emma, and Rebecca, and Tom, who's not in Glasgow, but Tom is from University of Exeter and University of Bath. I think it's split between the two. So it's not just University of Glasgow. And then tomorrow, our timings are a bit different. We have 10 a.m. British Summer Time, because we've got speaker Professor Yuki Nagai from Japan, and then we've got Professor Tamar Weiss, and then our own Tom will be talking about his research as well. There'll be a morning session. But again, if you can't make it, it'll be recorded. Watch it on YouTube, comment and share, and tweet about the conference. Thank you, everyone. And I'll see you, hopefully I'll see everyone over the next few days, and we'll stay in touch, because I think we've started quite a lot of interesting conversations.
Lovely. Thanks, everyone.
Thank you.
everyone.
Bye.
Thanks. I'm going to just stay to make sure we've got our little theme.